Welcome back. Today we're going to check on Pallet, and we're going to start directly at the README. So just a recap, in the Substrate template, at the base level we have our pallets. After the pallets, we have our runtime. Then finally we have our node. And all this, what pallets do, what the layers do is that they provide levels of abstraction. And finally, at the top is when we have the node. We'll go to the README section and try to figure out what a pallet is. So the runtime in this project is constructed using many frame pallets that ship with the core Substrate repository and a template pallet that is defined in the pallets directory. So we are provided with a pallet template, a template of a pallet that is defined in the pallet directory. So we'll navigate to that and try and read through the code. Okay, so here at the top we read that edit this file to define custom logic or remove it if it is not needed. Okay, so this is basically our boilerplate code where we can start creating our own custom pallet. And okay, so let's go through it. It's 109 lines. Okay, we have in the pallet module we have a pallet struct, unit struct. Okay, and it's generic. Then we have a config trait for our pallet module that extends the frame system config trait. And if you navigate to that, this other trait for the frame system, this is the system configuration trait that is implemented by the runtime. So the runtime implements the block length, weight, the call filter, the runtime call. Okay, block number, hash, account ID. Okay, it implements all that. And our pallet, just what our pallet does, it's that our config for our pallet, it extends that. It extends the frame system config. I think the reason why that happens is because here in our doc we read about dispatchables, and frame pallets define special types of functions that can be invoked from outside the runtime in order to update its state. So the fact that we have a pallet that extends this config that is also implemented by the runtime, we can probably mutate state. Yeah, we can probably mutate state that the runtime also mutates. We had discussed that the runtime is a state transition function. So pallets can do this sort of state mutation using dispatchables. Sorry. Okay, next thing we can check is this. We are reading through the code. Okay, so we have a runtime event, and because this pallet emits events, it depends on runtime definition of an event. Okay, type representing the weight of this pallet. So this is the weight information. The weight information is also a trait that provides where we must implement two. We must implement two methods: do something and cause error, which return a weight. What is a weight? A weight is a struct that the weight of computation time used on some reference hardware, the weight of storage space used by proof of validity. Okay, I won't go into that. I'll just read at a higher level. Okay, so for our custom palette, we have a wait info, and also we have a runtime event type that should be implemented by our palette, that our palette needs implemented. Okay, so this struct is what should implement this config, if I'm correct. Next we have the palette storage items. Okay, so we have a storage. This is okay, we have a storage mechanism here. Next, Pallet used events to inform users when important changes are made. Okay, we have an event type here, enum, it's an enum. Then we have an error enum, and here is where we implement our palette. In our palette implementation, we have our do something and cause error methods, which implement the config type, the wait info type, the wait info trait. Yeah, the wait info trait. Dispatchable functions allow users to interact with Palette and invoke state changes. These functions materialize as extrinsics, which are often compared to transactions. Dispatchable functions must be annotated with a wait and must return a dispatch result. Dispatch result. Okay. And that's the end of our Palette implementation. If we check at the README, it says Substrate uses events and errors to notify users of important changes in the runtime. When a dispatchable fail, it returns an error. The configuration interface is used to define types and parameters upon which a frame palette depends. Okay, I think before we end the video, we should check how the runtime, how its palettes were implemented. I think that would be helpful. If we go to the runtime src lib.rs within our substrate node template, we have okay, let's jump into where we have a palette that is being used. Okay, here what we looked at was I don't know the name of the palette. It was palette config. Okay, let me check. I would like to see these types being filled in runtime event and the wait info. Let's check if there's a palette that does that. Runtime event and wait info. Yeah. Let's take the palette grandpa as an example. We have a type runtime event, and we fill it with a runtime event. If you try to navigate here, it takes us to this runtime. But then again, we realize that where is it? Okay, this runtime event is something that the runtime implements within this larger config, frame system config. Still okay. There's something I don't still get. Runtime call the aggregated dispatch type that is available for extrinsics. Implement frame system config for runtime. Okay, so the runtime call and the runtime config appear to be coming from this block of code. but let me check. Sudo palette sudo palette sudo. Okay. Type. Frame sudo src. Sudo is what provides us with the runtime call and the runtime event, and that code is generated within this macro, if I'm correct. Code that deals with macro, I'm not really good with that, but basically that's what is happening, is that this information for the runtime event is generated at compile time by the construct runtime. Is generated at do I call it compile time? The compile time of the in compile time is when we have our macro expanded, but let me ensure that is correct. Do rust macros. Yes, so at compile time, this macro is expanded and we have our runtime event here, somewhere here. Okay, I think that will be the end of our video, and in the next time I'll post an example of my own sort of node. I was thinking of a voting application. I think that's a simple one to do, and it's something that is different from doing transactions. I can try a voting application where we create an election, register participants, and then create votes. I think that will be nice, and I'll try that with with Substrate. It will take a while, I know. I'm new to Substrate, so the next video will take about maybe 2 or 3 weeks, I'm not sure, depending on how things go. But I'll keep you guys posted, and yeah, drop comments, don't forget to like and subscribe, and you can also tell me what you'd like to see me post. Yeah. See you guys in the next one. Bye.